Hello everyone! Today, our group would like to present about the stabilizer. Before that, I would like to introduce our group member. The first one is Harif Fadila and the second one is Lukman Lutfi. The third one is Amir Irfan and the last one is Afif Nur Azizi. Next, we move to introduction. The stabilizer job is to provide stability for the aircraft to keep it flying straight. The vertical stabilizer keeps the nose of the plane from swinging from side to side, which is called yaw. The horizontal stabilizer prevents an up and down motion of the nose, which is called pitch. Now, we look at the stabilizer construction. Stabilizer construction is very similar to the aircraft wings. The internal structure of stabilizer consists of: the first one is spars and stringer, and the second one is fabric, plywood or sheet metal skins, and the third one is leading edge manufactured from the metal or composites. This picture shows the stabilizer skin on smaller aircraft can be manufactured with corrugation to add strength. Some aircraft are manufactured with a deliberate nose-down tendency. To counteract that, for straight and level flight, the horizontal stabilizer is manufactured with a cambered lower skin. Now, we look at the stabilizer mounts. On pressurized aircraft, stabilizer mounts are usually associated with the same structure as the rear pressure bucket, as this structure provides the strongest load path. This picture shows the location of vertical stabilizer, rear pressure bucket, and the horizontal stabilizer. Now, we move to the horizontal stabilizer. This picture describes most aircraft have a cantilever-type horizontal stabilizer. Now, I would like to invite Lukman Lutfi to present other slide.
Some aircraft have separate horizontal stabilizer which are attached to the fuselage by large hinge mounts. The stabilizer is allowed to pivot at the aft hinges and the forward hinges are attached to a jack screw. This is an example of aircraft Boeing 737 that attach jack screw on the horizontal stabilizer. This is the location of aft hinge mount, and this is where the forward hinge mount attached to the jack screw. Did you know that some large horizontal stabilizers are in one piece, joined together by a structural center section? Oh, like the Boeing 767? Yes! The center section is located at the aft fuselage or at the vertical fin by rear spar pivots. And the actuating arm is attached to a jack screw support, which enables stabilizer actuation. This is the location of rear spar pivot, and this is the location of the jack screw support. Some smaller horizontal stabilizers are movable one piece as a control surfaces, and they are joined together by a structural center section. The horizontal stabilizers are attached to the fuselage by hinge points, and They are actuated by a control cable attached to a counterbalance torque tube. This is the location of the hinge point, and this is where the torque tube is located. This is another view of the hinge point and the torque tube. In some aircraft, the horizontal stabilizers are separated with the elevator, and the elevator is located at the aft edge of the fixed stabilizer surface. This is an example of aircraft Piper PA-31P that have a separated horizontal stabilizer with the elevator. Okay, so that's all from me. Thank you. Here now is Amir Irfan. He will continue to explain more about horizontal stabilizers on aircraft.
Moving on, stabilizers are generally multi-spar constructed, meaning that stabilizers have 2 or more spars in them. Now, normally, there are 2 spars in stabilizers, one of which is the forward spar, which is located at the front half of the stabilizer, and then we have the aft spar, which is located at the back half of the stabilizer. Next, the forward spar is fitted through this opening and is bolted to the structure of the aircraft. The aft spar, on the other hand, is bolted to the aft bulkhead. As an addition, this is a zoomed image of the picture before, which shows the bulkhead, which is where the aft spar is bolted to. Although some horizontal stabilizers are one-piece fixed surfaces, meaning that they are fixed as one. For instance, we have the Cessna 402. The stabs are joined together by a structural center section which has attachment holes for bolting to the aircraft. The center section of the spars in the stabilizer are bolted to the aft bulkhead and to the aft former. This is a zoomed image of where the center section of the spars in the stabilizer is bolted to the aircraft. This is also a zoomed image of where the center section of the spars in the stabilizer is bolted at the former to the aircraft. For your information, a few horizontal stabilizers are fitted on the fuselage with a positive dihedral to supply additional stability. Now, I would like to pass on to Afif to carry on with the presentation.
Now, let's move on to horizontal stabilizer. Part of aircraft stabilizer configuration such as conventional tail, T-tail, seriform tail, H-tail, twin tail, triple tail, V-tail, inverted V, wide tail, bow-mounted inverted V-tail, and ring tail. Twin tail boom configuration to allow one forward and one aft mount engine to provide thrust in line with the center of the fuselage. Horizontal stabs are removed from wing turbulence and propeller slipstream by locating them at the top of the fin. Horizontal stabs are also mounted at the top of a fin to remove them from jet exhaust. Sometimes it's called a variable incidence tailplane, such as this aircraft Cessna Citation Longitude. Aircraft have different design of horizontal stabilizers and different methods of attaching them. They must all be checked for correct symmetry. It is to ensure that they are symmetrical with the wing and fuselage. Next, we're going to discuss about vertical stabilizer. Vertical stabilizers have a similar construction to horizontal stabilizers. The function is to give the aircraft directional stability. Some aircraft have verticals that have been deliberately offset during manufacture to counteract the effect of propeller torque. The internal structure of stabilizers assemble with spars and stringers running spanwise and ribs running cordwise, then wrapped with fabric, plywood, or sheet metal skins, and leading edges manufactured from metal or composite. The step is joined together by a structural center section which has attachment holes for bolting to the aircraft. The spars extend out through the inner rib and are fitted and bolted in the place inside the fuselage.